Hello, we are going to study capacitive type of displacement transducer. What is the function of capacitive type of displacement transducer? It will measure the displacement. It will convert into some kind of a capacitance. And so, if you want to learn displacement transducer, okay, which is of capacitance type, first of all, you should know what you mean by capacitance. And before knowing capacitance, you should know what you mean by a capacitor. Okay, you should know what you mean by capacitor. Just like if you know battery, if you know the word battery, okay, you can also understand the word voltage. Okay, voltage is nothing but which is applied, whatever is stored inside the battery is nothing but voltage. Okay, so similarly, if you want to understand a capacitive type of transducer, you should initially understand what you mean by capacitor. Then only you can understand the term capacitance. Okay, so what we are going to do today is we are going to start with this simple system. What do you mean by a capacitor? I hope you understood this thing. What do you mean by a capacitor? So if you have understood the capacitor, I would like to write something for you. Okay. If I want to introduce capacitive type of displacement transducer, so ultimately what do we need to understand is capacitance. Okay. What do we mean by capacitance? Capacitance is nothing but it is the ratio of, I'm just putting the definition for you. It is the ratio of charge, okay, to the voltage. Okay, capacitance is nothing but the ratio of charge to the voltage. I am telling this like if you know the unit of charge, you know the unit of charge is coulomb, and you know coulomb. If even if I have spelled it incorrectly, it's okay. Unit of charge is coulomb, and we know the unit of voltage is volt. Okay, so coulomb per volt is nothing but farad. This is what we call it as 1 farad. Okay, so whenever we see a capacitor, we know that it is storing some charge. Okay, it is storing some charge. Okay, and this charge is nothing but this charge is stored in the unit which is called as farad, and which is given by the term which is called as capacitance. Okay, now one more thing about capacitance which is very important to understand. Capacitance does not work only on itself. It can store charge. Okay, it can store charge but only for a small time. Okay, it can store charge but only for a small time. It cannot store charge always. Okay, this is very important. Okay, so we always require some kind of a battery. Okay, we always require some kind of a battery if you want to measure the, if you want to store, if you have stored the charge and if you want the charge to get repeated, what do you need in the system? You always need a battery. Okay, so now what I'm going to do is I'm just going to explain you how do we use this capacitor for, or how do you we use this capacitance type of displacement transducer to measure the displacement. Okay, so I am going to explain you capacitive type transducer. So this is one of my plate. Okay, let this plate be called as positive plate. Okay, and this is one of my, and this is, suppose this is my second capacitance. Suppose this is my plate. Okay, this is my one capacitor, or this is my positive plate, and let this be plate, this plate be called as negative plate. Okay, now what is there in between the capacitor is nothing but an insulating material. So this will have some insulating material. Why do we have insulating material? This is already mentioned. We have insulating material because we does not want, because we do not want the charge to flow, we do not want the electrons to flow from one plate to another plate. We just want the shift of electrons from one plate to another plate. Okay, so that is why what do we keep? We keep an insulating material in between these plates. Now there are two types of capacitive type of displacement transducer. One is linear. I'll just change the color. One second, I'll just change. There are two types of capacitance or capacitive type transducer. Yeah, one is linear. Okay, or you can say parallel plate transducer, parallel plate capacitor. Okay, so what I'm saying, one is parallel plate capacitor, as second one is cylindrical plate capacitor. I have drawn the diagram for both the things. One is parallel plate capacitor and second is cylindrical plate capacitor. Okay, there are two types basically. I've drawn both the two types. Now in the parallel plate, what happens, the plates are kept parallel to each other. You can see this plate and you can see this plate. Both the plates are kept parallel to each other. Both the plates are parallel. Now this plate will have some area A1, cross sectional area. Okay, this plate will also have some cross sectional area A2. Now you can see that there is some kind of effective area which is common area. This, if you can see, just look at this thing. So this is my common area. This area from this point to this point on this plate, and from this point to this point on this plate, the area is common. So this area is called as effective area of the plate. Okay, now the effective area of the plate is given by A, and the distance between the plate, there is some distance between the plate which is given by T. Okay, distance between the plate, this is not the thickness of the plate, this is the distance between the plate, capacitor plate. Okay, so I have given you two terms. One term is called as effective area of the plate, another term is called as distance between the plate. Now I would like to define for you what do you mean by how do you find capacitance, okay, for a linear plate capacitor. So the formula that you can use is epsilon naught epsilon r A by T. Okay, you can even use n minus 1, where n is number of plate. Now for this case, we know that the number of plates are only 2. We can use infinite number of plates, but here I am using only 2 plates. So if the number of plates is 2, so what I'll get, the capacitance will be equal to epsilon naught epsilon r A by T into 2 minus 1. So this will automatically be epsilon naught epsilon r A by T. Okay, and this is measured in, since this is a capacitance, this is measured in farad. Okay, this is measured in farad. Sorry, epsilon naught epsilon r. So sorry. Now what do you mean by this epsilon naught and epsilon r? I don't have that much space, but I'll still try to write. Okay, now what I'm saying, epsilon naught and epsilon r are constants. Epsilon naught and epsilon r are constant. This is called as permittivity or constant of free space. You can say it is a constant, or you can even say permittivity of free space. Okay, now free space is like this plate and this plate are also interacting with the environment. Okay, so whatever the constant or whatever the charge they are getting through the environment, that constant is called as epsilon naught. And there is one more constant which is called as epsilon r. This is called as constant of relative medium, or permittivity of relative medium, or you can say permittivity of insulating medium. I'll just share the notes, you don't have to worry about it. Okay, so this insulating material that you are going to keep inside or in between these plates, this is having some kind of a constant, or you can say permittivity, which is epsilon r. I think there is a question, sir. एक बार formula वापस से बता सकते हो क्या? Okay, I'll just put the formula once again for you. Capacitance, one second. Capacitance is epsilon naught, sorry, E naught nahi, epsilon naught upon, epsilon naught into epsilon r A by T into n minus 1. This is only for which plate? This is only for parallel type capacitor. So what I'm saying, what do you mean by epsilon naught? Epsilon naught is constant of permittivity of free space. Epsilon r is permittivity of dielectric medium. In this case, this dielectric medium is nothing but an insulating material. A is the effective area. Okay, if suppose there are two plates, this how can I show? Suppose this is my one plate and this is my another plate. Whatever might be, this both plates are having some area. Whatever might be the common area between these two plates. I am not telling about thickness, sorry, distance. I am telling about the effective area. So whatever might be the effective area, that is represented by A. Okay, that is represented by A, and whatever is the distance between the plate, that is represented by T. And N is nothing but number of plates. In our case, we consider the number of plate for the simplicity of the analysis. We consider the number of plate to be equal to 2 only. So this term automatically gets vanished. Okay, now this formula was for parallel type of capacitor. Now if I want to write this same thing for cylindrical type of capacitor, now there is another system which is called a cylindrical plate capacitor. In cylindrical plate, you can see this is a cylinder which is having a radius. Now you can see this radius is, suppose this radius is R2, and there is another cylinder which is inside this larger cylinder. Okay, this cylinder is having a radius. Suppose this cylinder is having a radius R1. Okay, now the length of the first cylinder, let the length of the first cylinder be L1, let the length of the second cylinder be L2, and we know the effective length will be equal to the length of the second cylinder in our case. So let the effective length be equal to L. So if you want to write the capacitance, you can write it as epsilon naught epsilon R, okay, again 2 pi L natural log of R2 by R1. So those who have studied physics, they know this formula. They have studied this formula. The capacitance for cylindrical type and the capacitance value for parallel type is given by this. Now we know that L is the effective length, R2 is the outer radius. Always remember R2 matlab, log, natural log of outer radius upon inner radius. Okay, so R2 is the outer radius and R1 is the, or you can say R2 is the larger radius and R1 is the smaller radius. Okay, this can be said as larger radius and this will be said as smaller radius. And this will also be, this will also have n minus 1. This term will also have n minus 1 automatically, since there are only two cylinders. Okay, cylindrical type this, there are only two plates, you can say. Since there are only two plates, automatically this will also have 2 minus 1, which will be also equal to 1. So automatically what you are going to have is capacitance will be equal to epsilon naught epsilon R 2 pi L upon natural log of R2 by R1. So this is it. Okay, now you have understood something about capacitance. Okay, now what I want to let you know, how do you use this thing to measure, okay, how do you use this thing to measure the displacement. Now just look at these two plates. This is my one plate, okay, just look at this plate. This is my plate 1, suppose this plate is positive, and this is my plate 2, suppose this plate is negative. So I'll just put it, this is my plate 1, okay, now this is my plate 2. Always remember, I am not showing the battery, but this capacitor will always have some kind of battery, because they always require some kind of voltage to get the charge into their system. Okay, so there will always be some kind of a battery. You don't have to worry that there will not be any voltage. There will always be some kind of a voltage that will be supplied. Okay, so what I'm saying, suppose this is my plate 1 and this is my plate 2. Okay, one is at negative terminal and one is at positive terminal. Okay, what I'm saying is, this plates, suppose these plates are holding some charge. Okay, these plates are holding some charge. Okay, so what will automatically happen, what I'm saying, now you know that capacitance, now this is nothing but this is some kind of a parallel plate capacitor. So what will be the value, epsilon naught epsilon R A by T, okay, n minus 1, we consider it to be equal to 1. So what I'm saying, let this plate, suppose this plate is fixed, I have fixed this plate. Okay, and this plate is movable, and this plate is movable, like suppose this is attached to the system, suppose this plate is attached to the system which is going to move to and fro. Suppose this system is going to move to and fro. Okay, this is my system and this is going to move to and fro. So when the system will move to and fro, automatically this plate that you can see at the top, this plate that is I have shown in blue color, this plate, I can say this plate, I can give this plate name as P2. This plate will automatically will automatically move to and fro. So when this plate will move due to the system attached to this plate, automatically the effective area will change. Okay, what will change is effective area will change. I hope you're getting. Okay, effective area changes. When this effective area changes, you can directly see, you can see from this thing, C is proportional to epsilon naught and epsilon R are constant. Since you are not going to change the insulating material, you are not going to change the air. Okay, so these two terms will remain constant. What will vary is A and T. Now, I am not varying the distance between the plate. This is the distance between the plate, right? I am not varying the distance between the plate. What I am varying is effective area between the plate I am varying. Okay, so I am attaching my system by, suppose by use of some arbor or shaft, I am attaching my system, okay, to this plate P2. So now when I am attaching this system to my plate P2, automatically when the system will move to and fro, suppose it moves in one direction, it will move. We actually don't measure something which is actually moving and which is covering some distance. It is just about minute displacement that is covered. Okay, and we need to know what is that minute displacement, what is the displacement that it is giving. Okay, so suppose this system is moving, it is moving in positive direction. So once it will move, this effective area will change. So what I'm trying to say, capacitance is proportional to area and capacitance is inversely proportional to distance between the plate. Okay, there are two cases that can happen. We can't change the dielectric medium because we are not changing the chemical affinity or anything. So we are going to keep these two things constant. Okay, so what we can change in our system, we can change the effective area between the plate, okay, or we can change the distance between the plate. Okay, I hope you're getting this is effective area, and this is the way displacement varies. Distance between the plate varies. Okay, so both are different things. It looks similar that this is also displacement. No, this is more about area change between the plate, and this is more about displacement change between the plate. Okay, so what I'm saying, there can be two cases. If you want to measure the change in the capacitance, the change in the capacitance can be measured by two means. What are the two means? One is changing the effective area. If you want to measure the change in capacitance, it can be measured by change in effective area. Okay, and second is changing distance between the plate. I hope you're getting distance between the plate. Okay, now I have considered the first case. Now I hope everyone can see that C is proportional to A. We all know that in our case, in this case, what we have mentioned, in this case where we have changed the effective area, we know that C is proportional to A. Okay, now if I try to plot capacitance, okay, with respect to area, just look at this thing. What I'm trying to do, I'm trying to plot capacitance with respect to area. Okay, so now I know that as area will change, capacitance will also change, right? And this will be more like linear. Okay, this graph will be linear because this is nothing but a linear relation, right? So automatically, when the capacitance, suppose I am expecting that at, suppose there is some initial capacitance value. So if I am changing the capacitance, okay, when I'm changing the capacitance, what I'm saying, capacitance change, automatically what will change? Area, effective area will also change. Now if I want to plot this thing in a different way, I can also plot it for something different. Just look at this thing. Just look at this thing. What I'm saying, suppose this is my capacitance and suppose this is my displacement. Okay, displacement of the system. Now just look at this thing. We know that when area changes, effective area changes, automatically what will change? Capacitance will change. And when effective area changes due to change in displacement. Okay, whenever there is some kind of a displacement, automatically effective area will change. Okay, so initially suppose both the plates were overlapping. Suppose both the plates were overlapping, or even if they were not overlapping, initially whatever might be the capacitance, that will be equal to some value, right? It will have some value. Capacitance will have some value at the start. It will have some value. Okay, when this plate, suppose this plate is fixed and this plate is moving. Okay, when this plate is fixed and one plate is moving, automatically due to the movement of this plate, automatically C will change, right? And when C will change, automatically when C is going to change, automatically what will vary? This C will be proportional to what? This C will be proportional to, or you can say the change in C will be proportional to what? Displacement. C is varying, that means effective area is also varying, right? And this is proportional, in our case, this is proportional to displacement, right? So if you can change the effective area between the plate, you can directly measure that thing in terms of displacement. We will see how do we measure C in terms of displacement as we proceed, but I just want to let you know that whenever C changes, automatically displacement will also change. I'm just taking second case. I'll explain you how does C leads to change in displacement by a solution or by a analytical method. But right now we will just consider these two things also. Now suppose there are two plates more. This is my plate 1. Okay, this is my plate 2. Okay, now suppose there is some kind of a charge which is nothing but voltage, because capacitance is nothing but, if you remember, that is nothing but charge per unit voltage. So suppose there is some kind of a charge, or you can even say there is some kind of a charge per voltage. You can say C by V, or you can even say there is some kind of an EMF, or there is some kind of a volt that is present across this plates. So there is one plate which is P1, and suppose there is one plate which is P2, where Suppose this is plus and this is minus. Now I am saying this is my arm and this arm is attached to the system. Okay, now again I am saying when this arm will, when this system will displace, automatically this arm will also move to and fro. Okay, when this arm will move to and fro, this distance will change. This is nothing but distance between the plate. So if I get to the next type, I can vary the distance between the plate. Now what I'm saying, distance between the plate is varied. Now this is not a linear relation. Just look at this thing. This is inversely proportional, right? This is something which is inversely proportional, right? So what I'm saying, just look at this thing, what I'm trying to explain. If I try to plot, one second. If I try to plot C versus T, now what I'm saying, if I try to plot, one second, capacitance versus the distance between the plate, automatically I know when C will be more. Just think about it. When C will be more, when T will be less. When distance between the plate is less, automatically, since C is inversely proportional to T. So when distance between the plate is less, automatically what will happen when distance between the plate is less? Automatically C will be more. So whenever the distance between the plate is less, okay, C will be more. Okay, and whenever the distance between the plate is less, I have taken, yeah, whenever the distance between the plate is more, C will be less. This is the way it works. Okay, so if I try to plot this thing, it will be proportional, but it will be inversely proportional, right? So it will be inversely, it can be linear, it can be non-linear, it depends, but automatically what we can say, this will be inversely proportional. Now C is more, T is less. You can see C is very high and T is almost equal to 0, and when C is very low, T is very high. Distance between the plate is high. So now if you alter the distance between the plate, what do we get? We know that when we alter the distance between the plate, again capacitance change. It will change in some kind of a way. It can be increasing capacitance, it can be decreasing capacitance, but one thing is for sure, whenever we change C, automatically the capacitance will, sorry, whenever we change distance between the plate, that is T, the capacitance will also change. Okay, now since I've explained you this thing, now I'll get to the main part where I'll explain you how does it function. How does a capacitor function? Okay, I've explained you two ways. What are the two ways? Can anyone let me know? Can anyone let me know? You can even let me know in the chat. What are the two ways? What are the two ways? Parallel type, right? And cylindrical type. Those are the types. What are the two ways in which you can change the capacitance? You can either change the, yes, you can either change the distance between the plate, or you can even change the effective area between the plate. Okay, now this is very important. This all was all about introduction. What we actually do in displacement, capacitive type displacement transducer, or capacitive type displacement transducer. This is the system that I have drawn just below this, what I'm writing. This is the system that we basically use. This is called as, just let me shift myself to a nice place. This is called as differential capacitor system. Whatever I explained you till now, okay, this was more of a theory of capacitor that you can write it in the exam. It's nice if you write it, but this is very important, differential capacitor system. Okay, so now what do you mean by differential capacitor system? First of all, get into the word of differential. Differential is nothing but some kind of difference. Always remember, you are feeding difference. Okay, where you are feeding difference, you'll get to know. But one thing is for sure, when you get to the word differential, it means difference. Whenever you see differential word, it is not automobile differential. Here, what I'm saying in measurement, whenever you hear the word differential, it means some kind of a difference. Okay, and this difference is nothing but some kind of a connection. Okay, electrical connection, which gives us difference of voltage, which gives us difference of capacitance. It can be anything. But one thing is for sure, whenever you see the word differential, you should understand that this is more about difference. Now, capacitor system. Now, when you get to the word capacitor system, you should be very sure that we are going to use some kind of capacitor. So now what I'm going to show you, suppose there are three plates. This plate, I should not say C1. This plate, let this plate be called as P1. Okay. There is another plate. You can see this black plate at the bottom. This plate is P2. And this plate, these two plates are at different position. This plate, let this plate be called as P3. Now, what I'm going to do, now these three plates, what I'm saying is, this plate is at a positive, okay, this plate is at a negative, and suppose this plate is also at a positive. Now we know that this two plate will form some system because these are positive and negative, right? This will have some insulating material in between. Now these two plates, positive and negative again will form some system. Okay, this will also have some insulating material in between. Okay, it will have some insulating material. Okay, that is what I'm saying. Okay, I hope you're getting. So this is my positive plate, another is my negative plate. Okay, so you have understood this thing. So what I'm saying, I'm supplying some, suppose I'm supplying some EMF, or I am applying, I am putting some battery into it. I am using some battery. Now, if I'm using some battery, first of all, you should know this two system, this plate, this two system, this positive and this negative will have some EMF, or this will have some voltage. Automatically, this system and this system will also constitute of some system. Now, let this plate be called as plate 1. Let this plate be called as plate 2, and let this plate be called as plate 3. What I'm saying, plate 1 and plate 2, when I'm applying, when I'm giving some battery supply to this system, this capacitor kind of a plates, there are three plates. Now when I'm giving some EMF, or I'm giving some voltage, okay, this will have some voltage E. Now this voltage will get the total voltage that I've applied across this system of my capacitor. Okay, what I'm saying, this 1 and 2 terminals will have some division of voltage, and 1 and 3, sorry, 1 and 2, 1 and 3, sorry, 1 and 3 will have some voltage, and similarly 1 and 2 and 3 will also have some voltage. 1 second. 1 and 3 will have some voltage, and 2 and 3 will also have some voltage. Now if I am giving voltage E, this will have the voltage division, this will have the voltage E by 2, and this will also have the voltage E by 2. How did I know that this will have equal voltage? Since I know actually that C1 and C2 are equal right now. Why they are equal? Because both the plates are at an equal position. This plate and this plate are having equal distance as compared to this plate and this plate. Initially, the distance, this distance, let this distance be called as T1, and let this distance be called as this distance be called as T2. Now I know that this distance are equal, and effective area between the plate, you can see effective area between the plate is also equal, right? So A is also equal and T is also equal. When A and T are equal, we know the formula, C is equal to epsilon naught, epsilon R. I hope you remember A by T, right? So if this is constant, this is constant, this is constant, and this is constant for both the plates, automatically C1 and C2 will also be constant. So now we are very sure that C1 and C2 are initially equal, because initially we are not varying anything. Now what I am saying, after some time, this plate 3 moves to a new position. Let this plate position be called as 3 dash. It moves by a distance x, okay, and it comes closer to which plate? It comes closer, suppose it is coming closer to which plate? It is coming nearer to plate P2, so it will automatically move far away from the plate P1. So now if this plate is moving by a distance x, now I know that C1 and C2 will change. Why they will change? Suppose this plate is having the capacitance which is equal to C1. This system is having a capacitance which is equal to C1, and this system is having a capacitance, sorry, this system is having a capacitance which is equal to C1, okay, and this system is having a capacitance which is equal to C2. Now I know that C1 and C2 will vary. Now if I want to write C1 will be equal to epsilon naught. This is not E, huh? I'm so sorry. This is epsilon naught, epsilon R. A is constant. What is varying is T. Now T is getting increased. For C1, T is getting increased. So for C1, it will be T plus X, right? And C2 will be epsilon naught, epsilon R, A upon T minus X, right? I hope you're getting. I have just changed what? I have just changed the capacitance. Okay. Now, if the capacitance is changed, just look at this thing, what I'm saying. If the capacitance has changed, Okay, initially what did I say? Both the capacitor were having equal EMF E by 2 E by 2. Now if capacitance is changing, automatically this value should also change. C1 was having a EMF which was equal to E by 2, C2 was having an EMF which was equal to E by 2. Now EMF will also change. Now if I want to write E1, just look at this formula. E1 will be equal to C2 upon C1 plus C2 into E. This is the basic formula. If you want to find the voltage division across the capacitance, there are more than two capacitance, so you will write C1 plus C2 plus C3. Okay, and here you will write, suppose there were three capacitance, suppose there was C1, C2, C3, there were three systems. So what you'll write at the top is C2 plus C3, and at the bottom you will write C1 plus C2 plus C3. I hope you're getting. Okay, so now in this system, how many EMFs are, how many capacitance are there? System is having only two capacitance. Okay, so if the system is having only two capacitance, what I'm saying, E1 will be equal to E upon C2 upon C1 plus C2. Now if you want to verify that, initially what did I say? Let this plate have an EMF which is, initially let this plate have an EMF E1 which is equal to what? E by 2, and then let this plate have an EMF E2 which is also equal to E by 2. Now if you want to cross verify, you can even cross verify with this formula. Just look at this formula. E1 will be equal to E. Now you know that C2, let C2 is equal to what? C. When C1 was equal to C2, C2 was equal to what? You can write C, and C1 plus C2 again will be equal to C plus C. So this is how much? 2C. So you can cancel C. What you're getting is E by 2. Similarly, if you want to write it for E2, you will write E. Since it is E2, you will write here C1 upon C1 plus C2. Now again try to verify. What you'll get is E2 will also be equal to E by 2. Okay. I hope you're getting. Is everyone okay? Just let me know in the chat if you're understanding whatever I'm saying. Put it as fast as possible. We don't have much time. Write it as fast as possible. Yeah. Everyone. Should I start? Should I? Okay. Okay. Now just listen to what I'm saying. I'm trying to make it as simple as possible. This is a very difficult task because to make people understand electronics and that too of mechanical stream is very difficult. So I'm trying to make it as simple as possible. Just try to understand. Now what I'm saying, E1 is equal to E, okay, C1 upon C1 plus C2. Now E1 will be as it is, E will be as it is. Okay, now you know the value of C1. What is the value of C1? We have already found the value of C1. Epsilon naught, epsilon r, you can see here. 1 second. You can see here epsilon naught, epsilon r upon into A upon T plus X. So what I'll do here is, 1 second, epsilon naught, epsilon r, A upon T plus X, right? Similarly, epsilon naught, epsilon r, this will be constant, A will also be constant. What will remain is A 1 upon T plus X plus 1 upon T minus X, right? Now I'm just trying to simplify. Now look at this thing. Epsilon naught is getting cancelled, epsilon r is getting cancelled, E will be as it is, A will also get cancelled. So what will remain is E upon T plus X. Okay, now I'll try to simplify this thing. This will be like T minus X plus T plus X. Don't do T square minus X square. Keep it as it is, T minus X into T plus X. Now you can see T plus X will get cancelled. What will remain is E into T minus X. This will go to the numerator, right? So this will be E into T minus X upon, you can see this and this term will get cancelled. What will remain is 2T, right? So what you have got from this is, you have got some kind of a voltage E1 which is equal to what? E1 is equal to what? I hope you're getting E1 is equal to what? E by 2, okay, into T minus X upon T, right? Similarly, if you try to find for E2, what you will get, I'll just write it directly. E, you will get T plus X upon 2T, okay? Now, this is the value that you're getting, okay? Now, why do we call this system as differential? Now, I will let you know. Now, we know that this, just let me write something. These two plates are having a EMF or voltage which is equal to E1, and again another plate is having a voltage across it which is equal to E2. Now the voltage across this two plate, okay, voltage across this two plate and voltage across these two plates. Okay, we will feed into some kind of a system, okay, which is called as differential system. Now, I have already told you differential system means some kind of a difference. So when you study differential capacitor system or differential voltage system, you always take the difference of whatever is your output. Okay, so now we know that our output, you can say our output is capacitance. You can even say our output is when the plate is changing its position, what is changing is its voltage is changing. So we need to feed this output so that we get difference of voltage. Okay, so now what do you need to do? Suppose this is my terminal 1, this is my terminal 2, this is my terminal 3. So terminal 1 and terminal 2 is giving E1, terminal 2 and terminal 3 is giving E2. So now what I'll do, I'll try to feed this both signal together into a system which will take minus of both the signal. So I am trying to find difference in the voltage across the capacitor plate. So this is called as, you can write it E1 minus E2 or E2 minus E1, whatever is the larger, which one value is the largest, which value is the larger. If you just look at this, this is having, so sorry, 1 second, let me complete. One second. Huh? You can see T plus X will have larger value, right? So T plus X is a larger value, another is having T minus 1. So what I'll do, automatically E2 minus E1 will happen. So E2 minus E1 rahega, so this will be like E upon 2T is constant. I am feeding the signal into a differential system. Differential system does what? Differential system takes the difference of the two voltages. Okay, so what I am saying, E by 2T will be constant. What will remain in the system is T plus X, right? Minus of T minus X, right? Right now? So what will happen with this is E by 2T. Just look at this thing. So T plus X minus T plus X, right? So what is getting cancelled? T is getting cancelled. So what is remaining? What is the differential output voltage that I am getting? What is the difference in the voltage across the? You can use this. You have already seen this kind of system, like plus and minus, plus and minus. Now what you have to do, you have to take one voltage which is positive as plus, and another voltage which is one voltage which is at a higher value as plus, and another voltage which is at a lower value. You have to subtract from the initial. So you can do this thing. This is not a difference. This is not a problem in electrical system. So what will remain is E by 2T into 2X. Now if you just try to understand, what you'll get is E is equal to X by T, right? E is equal to what? Delta E is equal to X by T. Now just look at this thing. This was what? Just look at this thing what we have got. Just look at the output. I want everyone to look at the output that we have got. Just look at this thing. I hope everyone is able to see. What we have got, delta E is proportional to E into X by T. Delta E is proportional to E into X by T. Now, T was the thing that we are changing, right? T is nothing but the distance between the plate, right? Distance between the plate that we are changing. Now we can measure this thing. This is actually measurable. And what I'm saying, this distance between the plate which is changing, this is proportional to what? This is proportional to X, if I'm not wrong. Yeah, this is proportional to what? This was the initial, sorry, this is not the distance. This is the initial distance between the plate. T is the initial distance between the plate, and this is the distance which is changed, right? So what do we get? This is going to be constant. Initial distance is a constant. E is also a constant. So the change in voltage will be proportional to what? X, right? Right? So whatever output that you are going to get, that will be nothing but this displacement is happening due to what? Due to the displacement of the arm or displacement of the system. I hope you're getting. So you don't have to measure. Even if this displacement is very, very minute, this is very, very, very small. You can't measure it with your naked eye. I hope you're getting. This is very small and this is instantaneous. Okay? Even if this displacement is very small and instantaneous, you can measure it in terms of, what? Change in voltage, right? And this change in voltage will be calibrated to what? This change in voltage will give us what? This change in voltage will let us indicate, will let us know what is the displacement of the system. Okay? Is everyone clear? I have tried to explain you. Now, capacitance system is there, but capacitance system is using what? Voltage. I hope you're getting, but all the things are correlated. I have used the capacitance method only. C1, C2, I have used all these things. And what I have tried to deduce, I have tried to deduce that whenever the capacitance is changing or distance between the plate is changing, actually what will happen? There will be change in voltage which can be detected automatically. Is everyone clear? Okay. Now I'll just read out some advantages. There are limitations also, but we are looking for advantage. First is this is very easily fabricated. Okay. Second, it has high frequency response. High frequency matlab you can even measure the smallest of the signal. Okay. This is what I've mentioned. This can detect the smallest of the signal. And what is the value of the smallest of the signal? You can see it can measure even the signal of the range 2.5 into 10 raised to minus 6 meter. I hope you're getting this is as small displacement as possible. So it is, and सबसे पहले it is an electronic system. Okay, this is a passive transducer. This is its disadvantage. It is a passive transducer. When it is a passive transducer, it will require some kind of external source for its output. So one thing is it will have easy fabrication. It has high frequency response, like it can detect the smallest of the signal. It can give linear output since delta is proportional to x, and I already told that the system that we actually use for displacement transducer is differential capacitor system. So it is used to measure, it can give linear output, then it can measure static signal as well as dynamic signal. It is used to measure the liquid level and the gas level. Even if it is changing by minute, and if you want to respond, if you want to measure that thing, so that you can take the necessary precaution. So in those kinds of system, we use capacitor. So capacitance is, or the capacitive type transducer is actually used in thermal power plant to measure the displacement of liquid or gas level. Okay. Next, it is having very low initial cost. Okay. And it is having low maintenance cost. I hope everyone is okay.